In this video, I want to look at the cases of resolving a vector. Already I've explained what is the resolution of a vector. That is, it's a process of splitting or breaking down a vector or vector quantity into two perpendicular components. Now look at this boy. The boy is pulling this car by means of a string or a rope that is attached to the car. And then T is the tension in the string. Now, while this boy pulls this car, you notice that this car will move forward in the direction X, positive X direction. And it's also possible that the front side of this car will be raised up. Yes, why is this so? Because the tension that is supplied through this string has two components. A component of it is acting vertically upwards. That's the vertical component. That's the component that tends to raise the front side of the car in the upward direction. And then the other component is the one making this car to move forward. What are these two components? We can get these two components by resolving the tension T in the string. That is a force that is applied through the rope to move this car in this direction. So I can call that my Tx component and then my Ty component. My Tx component is the horizontal component in this case. We call that the horizontal component, and my Ty component is the vertical component. Okay. Now, using SOHCAHTOA once again, this is my Ty component acting upward because this component acting in this direction is same as this component is trying to lift the front side of the car upwards. My Tx component acts along the horizontal, that is along the ground, and that is the component that is responsible for moving this car in the forward direction. So by SOHCAHTOA, this is opposite a half sine theta equals opposite Ty over the tension in the string T. So that gives me Ty equals a T sine theta. Now suppose angle theta is given. Let's say that the theta is given as the angle the rope makes with the horizontal is 30 degrees and the tension in the rope is 60 Newton. Therefore, the Ty component is going to be 60 sine 30. That will give me 30 Newton. And then the Tx component, that is a component of the vector that moves the car in the forward direction. So it is given by, adjacent over hypotenuse, that is cos theta, which becomes T cos theta. So that if T is T60 cos 30, and that gives me 60 multiplied by 0.8660. Okay. Tx roughly gives me 52 Newton. So you can see that the forward component, the Tx component, is greater than the Ty component. Means that this car moves forward more than it moves upward. Now again, you will reverse. You can decide to change the setting of this question. What do I mean by that? They can give you the value of the Tx, that is the component of the tension in the string that moves the car in the forward direction. They may give you that, probably 100 Newton, and they will ask you to calculate the actual tension in the rope. This one, and Tx is given. Of course, Tx is T cos theta. So if Tx is given and this cos theta is given, which means to find the actual tension in the rope, it is Tx divided by cos theta. So that is the case when, because sometimes you can switch the question, you can twist the question and decide to give you, instead of making it direct, calculating the horizontal and the vertical component, you'll be given one of the components and you'll be asked to calculate the actual tension in the rope. Okay, look at another case. This is a case 2. In this case, we have this inclined plane. This is a plane surface that is inclined at angle theta degrees to the horizontal. And then we know that the weight of a body always acts vertically downwards. So this is the line of action of the weight. Now, if the plane is smooth, you notice that when this block of mass is released, it's going to start sliding downwards. It slides downwards. This gives the direction of motion when the block is just released from rest, which means, according to Newton's first law of motion, a force must be responsible for the motion, for the downward motion of this block of mass. No. The other forces, of course, we have the normal reaction. The normal reaction is acting perpendicular to the surface and it's not in the direction of motion of the block of mass. The weight of the body is acting vertically downwards and it's not also in the direction of the motion of the block. The block moves along the plane, which means there must be a component of the weight of the body that is responsible for the motion, for the sliding down of this block of mass along the plane. So to get that component, we need to resolve the weight of the body. We do something like this, making this up to a right angle triangle. Call this our adjacent. So the weight of the block acts along this line, and then the component along this line is called the component of the weight. This line, this side of the right angle triangle, is called the component of the weight of the body that is acting along the plane surface, along the plane. Sometimes they call it the component of the weight parallel to the plane. So how do we get this component? And that's the component that is responsible for the motion of this block along the plane. Then the second component of the weight, when it is resolved, is acting perpendicular at right angles to the plane. We call that the component of the weight that is perpendicular to the plane. How do we find these two components? Maybe I should leave that to you. How do you determine? This parallel component is also acting the same as this. These two lines are both parallel. So whatever we have here is the same as the component of the weight acting along the plane. So if I refer to my SOHCAHTOA, I have sine theta. This theta here equals opposites. Okay, maybe I should call this one WX. That is a component acting along the plane. WX, which is also a component acting along this line, opposite over hypotenuse this. So that gives me WX is equal to the weight of the block multiplied by sine theta. And they recall that the weight of a body is defined by the product of the mass of the body and the acceleration due to gravity. So this is mg sine theta, and that is a component of the weight that is acting along the plane, that is responsible for the motion of this block down the plane. Then the other component, using the cosine, cos theta, gives you, let's call this Wy. That's the component that is acting that direction, divided by the weight. That gives you Wy equals W cos theta. That gives me mg, which is the weight of the body, multiplied by cos theta. Now, this component, mg cos theta, is not it's not unbalanced. That is, it is balanced by the normal reaction that acts at right angles to the surface of the plane. So this is one way we apply the resolution of vector to determine the two components of the weight of this block, one of them acting parallel to the plane. That is the component responsible for the motion of the body. So let's say we have this case. Look at this case where a nail is attached to a wall, and then a boy tries to remove this nail by means of the string. The string is attached to the edge of the nail. This is the nail, this is the head of the nail. And it's very simple. If this boy wants to make its work very easy, we'll have applied the force along this line, and that can easily pull out the nail. But look at the direction of action of the force applied to the nail through the string. It makes angle theta degrees to the vertical. And now they may ask you in exam that what is the effective force, or what is the force that is effective in removing this nail? Of course, you agree with me that the effective force in removing the nail is that force that acts along the x direction. This is the direction of the force that is effective in pulling out this nail. The second component of this force F is acting vertically downwards. Let me call that one Fy. This Fy component is just there to bend the nail. But the force that is effective to pull out the nail from this wall is the one that acts along this x line, along the positive x direction. I can call that Fx. So by resolving force F using this triangle, well, this side of the triangle is the same, is parallel to this x direction. So my Fx component is also acting along this line because this is parallel to this. So from SOHCAHTOA, if I have to start by writing down sine theta, this is my opposite side because this is right angle triangle. So this is my opposite, this is my hypotenuse. That gives me Fx over F. It means that the Fx component is F sine theta. So given the values of F and theta, let's say for instance theta is 30 degrees and that F is 20 Newton. It means that the component of the vector force F that is effective, we remove the nail, is 20 sine 30. Sine 30 is 0.5. That gives you 10 Newton. So this is a component of the vector F that is effective in pulling out the nail. Another component that bends the nail is the Fy component, which is going to be F cos 30 because this is adjacent over hypotenuse. So that gives me 20 cos 30. That gives me 20 times 0.866, which will give me 17.3 Newton if you multiply that. So this is another way we apply the resolution of vector to resolve this particular force that is applied to this nail, acting, the two components are the Fx component and the Fy component. So lastly, I want to look at this case. Now look at this particular force F acting at angle theta degrees to this direction, the y direction, and this force is acting at this surface. We want to resolve, it's possible to find the two components of force F acting perpendicular to the surface because this line is normal. This line is at right angles to this surface area. So there's a component of force F that acts along this line. We're going to resolve this force F to get that component. And then there's a component of force F that acts parallel that is parallel to the surface. That component acts this way, just like holding your pen this way. You resolve this vertically and you also resolve it horizontally. So if you're asked to find the normal component, Fn, I can define that as the normal component of force F. Normal component of F. That is a component of F that is perpendicular, acting in a direction, 90 degrees to the surface. In case that is required, what do we do? What's the expression for that component? And the component that is parallel to the surface, I can call that the Fp component. That is a parallel component of force F. Now we use of course this is a right angle triangle. I expect my Fp to act along this line and my Fy along this line, that is Fn, normal component. So by SOHCAHTOA, this is opposite over hypotenuse. So sine theta gives me Fp over F. So the component of F that acts parallel to the plane is F sine theta. Okay, so if theta and F are given, you can find that. And the component is acting perpendicular to the plane. Of course, if I use cosine, cos theta gives me Fn over the total force, so that Fn equals F cos theta. Okay, so this is how to resolve a force that acts at an angle theta degrees to this normal direction. We need that there is a component of force F that acts at right angles, that acts along the normal, perpendicular to the surface, at right angles to this surface. And we have another component that acts parallel to the surface. So this is how to get the two components.